Okay, hello everyone. I'm Nick Coombe from Solway Firth Partnership, and this talk is part of a project managed by Solway Firth Partnership to help you find out more about archaeology on the Rhins of Galloway. It's supported by the QGIS Community Fund, and the project includes 3 online guides that are available on the Solway Firth Partnership website, as well as a series of talks, of which this is the second. Another takes place later in the week as part of Archaeology Month, and it's about place names. But today we're LiDAR, and Graham is our host. So I'll hand over to you, Graham.
Thanks, Nick. Hi everyone. Good evening. My name's Graham Cavers. I work for AOC Archaeology, and we're working with Nick and the team on the Rhins Coast Path project. So I'm here to talk to you about LiDAR and archaeology, and how the ways that we use LiDAR to help us detect new archaeology and to understand the archaeology of the areas that we're looking at better. So this will be a kind of whistle-stop tour through what LiDAR can do and how it helps archaeologists. And the main parts of my talk are just going to be about what LiDAR is, first of all, like how it works, and what it can do. So what it can give archaeologists in terms of tools for looking at the landscape and understanding it better. We'll spend a bit of time just looking at how you can access LiDAR, because we're quite lucky to have access to free LiDAR in this country, so we'll have a look a bit at how you can do that. And then finally, I'll just mention, just at the end of my talk, some more advanced tools, because this talk is partly talk and partly workshop. So we want those of you who are interested in looking at this data more closely yourselves to know where you can get started with that. And if any of you are interested in following up on that, then please do contact me, and we can discuss further sessions. So we'll not spend too long on the advanced stuff at the end, but because that's not for everyone. But I'll mention it just in closing. So as I say, we're really lucky in Scotland because over the past few years, the past sort of decade or so, the amount of LiDAR that has become available is increasing all the time. This map is actually even now, slightly out of date because there's new areas being added to the online data set of LiDAR. But this stuff here that you're looking at on this map is the freely available LiDAR for the country. And because this was paid for by public funds, the Scottish Government has made it freely available to everyone on an open government license. So if you look up the Scottish Remote Sensing Portal, you'll see this is the map that you're able to browse and see where that data is available for download. So you can see that we're getting close to the stage where most of southern Scotland is covered now, and it's really quite an amazing resource to have at your fingertips. And it's not just archaeologists that make use of this stuff, but obviously it's incredibly useful to us in our studies of the landscape. So that just gives you an idea of how much of it is coming online. And as I say, every year more gets added to it, and every now and again a new batch of data is released through this remote sensing portal. So it's worth keeping your eye on, especially if there's an area that you have in mind of particular interest. So just to say a little bit about how LiDAR works then, just to give the very sort of brief overview of the technology. Basically, the principle is that LiDAR is laser scanning. LiDAR stands for light detection and ranging. So it's effectively the light version of what radar is. That's how it gets the acronym. So that's what LiDAR stands for. And basically, it's a type of laser scanning where the laser scanner is mounted on an aircraft, and that aircraft flies in systematic swathes up and down the landscape, taking thousands of measurements per second. Thousands of measurements per second of the landscape. It's scanning the ground surface as it moves along. And because the aircraft has GPS mounted onto it, it's able to control the position of that sensor very accurately. So we're able to get this sort of very extremely accurate and high density data set for the ground surface as the plane flies over it. So each individual measurement that is taking, these thousands and thousands of measurements every second as the plane flies around the landscape, each individual measurement is has a typical accuracy of around about a handful of centimeters. So if you can imagine all of these individual measurements, they're basically X, Y, and Z coordinates in the same way that you could produce with a tape measure or with a theodolite or any other sort of surveying technique. But each of these is just an individual measurement of the ground. And so any individual point isn't much use on its own. So what we have to do when we're looking at LiDAR data is we kind of aggregate these measurements into a continuous surface. And this slide here just kind of illustrates how that process is done. If you can imagine this array of dots at the bottom is what we call the cloud of points, the point cloud measurements of the ground surface. Effectively, the processing software that we use to turn that into something usable turns those points into a grid, also known as a raster, a bit like a JPEG image. So, except that each pixel in that image is a height value rather than a color. So where you might take a photo on your digital camera and you get a color image representing the thing you've taken the photo of, this process is very similar, except it's converting height into pixels. Okay, so that's quite an important concept to have in your head when you look at LiDAR data, because this is very much three-dimensional data. It's not just 2D mapping, and that's important for some of the reasons that I'll come on to in a minute. Now, we quite often hear a lot about LiDAR in the news these days because of its supposed ability to see through trees and vegetation and things. And that's something that I always like to get across to people, is that that's a misunderstanding of how this stuff works. LiDAR never sees through anything. It's based on laser pulses, so laser beam bounces off the objects that it's scanning. So anything that laser hits, whether it's a tree or whether it's a bush or a building, it will reflect the laser back, and that will be the measurement that's recorded by the sensor. But what modern LiDAR systems are able to do is, this diagram just illustrates how, if you imagine the laser beam coming down from the plane, some parts of that laser beam manage to find their way through the gaps in things like branches and trees. And by using a kind of filtering technique, the sensor is able to tell the difference between the pulses that made it to the ground and the parts of the pulse that were reflecting off the first return or the first bounce back. So when people say that LiDAR sees through trees, that's not strictly correct. But what it does do is it gives us the ability to filter those first measurements, those first return measurements against the ground surface to produce what we call a bare earth model. So that's obviously really important for archaeologists, and this slide just gives a kind of nice example of how this is so effective for recording things like earthworks. So much of our archaeology in rural Scotland is in the form of upstanding earthworks, things like hill forts, like these examples here, but also things like hut circles, chambered cairns, standing stones, stone settings, all of this kind of archaeology, but particularly earthworks, it responds very well to this kind of high resolution 3D modeling technique. So these two images here are from examples of forts in the borders, and you can just see the difference that you're getting in the level of detail in these images to something like a traditional aerial photograph, for example. So we're able to see these very slight and minor changes in topography, the kind of lumps and bumps in the ground that give away the presence of archaeological features. So in this example, this is Coburn Law. You can see the very faint trace remains of this outer earthwork here, the complex of inner defences, and then the kind of lumps and bumps that indicate the presence of hut circles and house stances within that enclosure. And the same in this image on the right here, you can see these very small circular features just accentuating the micro topographic changes in elevation that give away the presence of structures. So again, very different to something like a traditional aerial photograph or a satellite image. We're able to pull out these kind of very faint details and accentuate them in these images. One of the reasons I spent that slide just a couple of slides back explaining the process of turning the point cloud into this raster image is because that's important for the way that we're able to manipulate the data. So you'll typically see LiDAR depicted as this kind of grayscale, this hill shaded model here. And that's quite a standard way of doing it because the human eye has a kind of natural understanding for things that look lit from a certain direction. So if light is cast across something, you can interpret that as being 3D. So you can see in this image, you can see the promontory here with the fort and the earthworks inside. It looked quite realistic, even though there's no naturalistic color. But the other thing that we're able to do is because this is three-dimensional data, we're able to apply further filtering processing routines to it. One of the most useful of which is to take away the general trend in the landscape pattern. So if I just move to the next slide here, you can see this is exactly the same data as was in the previous one, but all that's been done to this image is it's had the general trend of the sort of the wider topography taken away from it. So what you're looking at is height differences in relation to the local topography. So things like you can see, for example, within the fort, you can see again an example of this little circular structure, almost certainly a house stance, but we've got much more detail in the earthworks themselves. And in the surrounding landscape, you can see the trace remains of rig and furrow agriculture. So we're getting a much sort of deeper time depth in this image than we had just from the traditional hillshade. So why was this data collected? And this is, again, just something to emphasize in thinking about what we can do with the data and what tools it puts at our disposal. So first and foremost, the LiDAR that's available to us in Scotland was collected for things like flood modelling and for renewable energy modelling, that kind of thing. To a lesser extent, research by organisations like SEPA use this data for things like groundwater modelling. So it wasn't principally first and foremost collected for archaeology and heritage purposes. And that is worth bearing in mind because there are some limitations with what you can do with the data. Archaeologists always want the most high resolution data they can get their hands on, and that's not always that the resolution is suitable. So when you're looking at this stuff that you can get from the remote sensing portal, generally speaking, the later data is the better quality stuff, the higher resolution stuff. And for the most part, the resolution of the data that we're able to work with on the remote sensing portal is sort of ½ meter. So the pixels in each of these images is about ½ meter on the ground surface. And this is just, this slide just gives you a bit of an illustration of how this sort of process works. And this illustrates the point cloud here. So in this image, you can see, this is just a clip of the data out from a typical bit of data that you could get from the remote sensing portal. You can see in this image, the yellow blobs here are the roofs of buildings. And this is just illustrating how the processing routines that we can use are able to differentiate and distinguish between things like buildings that are built up from the ground. And then in this case, the blue dots are illustrating the sort of low down vegetation and points that are close to the ground surface. So you can see just by using this kind of three-dimensional approach, we're able to filter out things that stick up from the ground, from the bare earth itself. And of course, that's what archaeologists are very keen to do because we want to see the ground surface beneath. So this is an example of that same data that we were just looking at there, that three-dimensional point cloud converted into one of these hillshade models. And you can see how it's got this sort of silver and gold shimmer to it. And that's because in this particular treatment of the data, we've used something called a multi-directional hillshade. So I talked a little bit earlier about converting these images into something that looks almost naturalistic to the extent that, you know, the human eye can read it and understand that it's a three-dimensional model. But one of the things in archaeology that we're quite keen to do is see all of the detail in the ground surface. And if you imagine a landscape like the one on this slide here, for example, you can see that we have some quite deep gullies in these valleys down here, and we've got long open expanses of hillside here, and what that results in is we can get some really sort of stark shadows in some areas. You can see in this valley, for example, we've got the artificial lighting that we've used to create this image ends up with a sort of deep shadow, which could potentially mask features that are of interest. So we tend to use these different lighting techniques to accentuate the treatment of the 3D data in the landscape, and, you know, accentuate these very small micro topographic features. And also we're able to use these multiple directions of lighting. So instead of just casting light from one direction, we use several at the same time, and that really helps pull out the archaeology from the bare earth model. So I said a little bit about the ability to deal with vegetation and strip off things like trees and bushes and give us detail of the ground surface underneath. And this is just quite a nice example of a fairly typical later prehistoric settlement that you might see in the Scottish landscape. So this is a fairly sort of typical shelter belt around an area of grazing, and you can see that it's covered in trees, bushes. If you go to this site, there's a lot of bracken. You know, it's very difficult to see what's on the ground. But this is quite a well-known earthwork fortification, Iron Age earthwork in the Scottish borders at the Bunkle Ridge. And you can see if we just use that same filtering technique, this is exactly the same image, but I'm able to strip off the trees and suddenly I'm able to see all these the details in the earthwork underneath. In this case, we've got a multi-phase late prehistoric settlement with earthworks overlain by later buildings and so on. So again, if you can imagine going to that site and trying to record it, even just measure it and take photographs of it, it's very difficult. I've been there myself, and it's chest high in bushes and bracken, but just having the ability to do that, just going back to the vegetation covered image and then to the bare earth model again, just stripping off to produce this bare earth surface is one of the things that's really useful to archaeologists. And that's kind of resulted in us being able to identify large numbers of new sites. So in areas that, you know, would typically be around the fringes of where archaeologists might look to survey, in these sort of difficult overgrown areas, we're finding lots of new sites and features and things that tell us about the depth of activity in the landscape. So it's just another example, just stripping off the trees along this shelter belt here. You can see right in the center of the image the earthwork of probably a little Iron Age enclosure here. So even in these sort of fairly well-known areas of Scotland, you know, the parts of southern Scotland that are actually quite thoroughly surveyed, we're still turning up these new features, new unrecorded features in areas that would have been very difficult to survey any other way. And again, just to sort of to emphasize that point of looking at the details in quite well-known sites. This is a site in East Lothian. I mentioned it before, but again, just being able to pick out the relationship between the features in the interior of these sites by using these different visualization treatments of the data is giving us lots of new information. And even sites that aren't particularly well preserved, it gives us a new advantage in looking at the data, because this is just an example of a probably sort of earlier Iron Age enclosure. You can see the earthwork, trace remains of the earthwork here. And again, it's quite sort of typical upland southern Scottish late prehistoric settlement, in that it's got this big enclosure around it. And it just in the interior, we can see the very trace remains of these circular house stances here. But again, if you're to stand on the ground on this site, it's extremely difficult to try and disentangle the relationships between all of these features, and even difficult to establish the extents of individual structures. So having the ability to do this in 3D and visualize that data is really powerful. And this is just a good example because using again this same technique of taking away the overall trend in the landscape, so taking away the morphology of the hillside just to leave us with the very small changes in topography, you can see really accentuates the presence of those buildings in the interior. So you can see these dark circles here are the grooves that were cut to accommodate the timber posts that that would have held these buildings up, that formed the walls of these buildings. So, you know, so something that looks on the face of it not a particularly well preserved archaeological site, just with a bit of enhancement and a bit of manipulation, we're able to get so much more information out of it. And you can see that just by working with images like this alone, we're able to establish, you know, really quite sort of detailed descriptions and chronologies for some of the occupations of these sites. And the other thing is, because this is all digital data, it's not confined to one visualization, and we're able to merge these things together. And again, just for archaeological purposes, that can be really effective in terms of enhancing and accentuating these very small features. The other thing to remember, and something that's often forgotten, is I've shown you lots of the kind of typical 2D treatments of LiDAR. So we convert the point cloud data into two-dimensional images to make them into things that we're familiar with looking at. So they look like maps effectively. But the other thing to remember is that this is 3D data. So again, if you're working with LiDAR data, you're able to move this data around, look at it in elevation and profile view, and take things like cross sections through it, cut through the data. You know, look at the relationship between individual earthworks and their surrounding features. So, you know, this is all data that has so much potential for, you know, for asking new questions of the terrain for while you're working on reports and writing up data at your desk. So while field archaeology usually is sort of constrained to what you can fit in your time in the field, one of the great things about LiDAR is that it allows you to revisit these sites virtually from your desk and ask new questions of them. And again, that little animation that I showed you there was just merging some of these different visualization techniques with that 3D data. Some of you may have attended the talk that I gave a few months back about our work on the Rhins Coast Path at the Mull of Galloway. And again, I just put these couple of slides in because they're a good example of how powerful LiDAR can be in terms of visualizing the archaeology that you're investigating. So this is the Mull. Some of you, I'm sure, will know it very well. And this really complex earthwork, this sort of famously enigmatic earthwork that cuts off the Mull itself, is what we were interested in finding out a bit more about. And one of the things that we want to do is record that in more detail and understand it better, and take samples of the parts of it that are starting to erode. But you can see this, the LiDAR data gives us this really kind of high resolution documentation of the sort of morphology of the land of the earthwork, but also how it sits on the terrain and how it works in its local landscape. So this can be a really sort of effective way of not just visualizing it for presentation purposes, but asking new questions about, you know, what the purpose of that earthwork, what it might have been, why it sits in the position that it does on the Mull there, which is, you know, the subject of a much bigger and longer lecture. But you can see that these tools are sort of self-explanatory in terms of how valuable they are to archaeologists in terms of appreciating the position of these features in the landscape and helping us to explain what they might have been for. So the other thing that we did at the Mull was to carry out a geophysical survey. And again, because all of this three-dimensional digital data works so well together, this is all data that's been referenced in Ordnance Survey coordinates, just like the LiDAR data. So this kind of horrible black and white patchy image that you're looking at, this is fairly typical geophysical data, archaeological geophysical data. And again, without going into too much detail about the contents of this survey, there's quite a lot of evidence for structures and features within this data. So these these white lines, for example, are almost certainly of archaeological origin. These big black and white dots are highly magnetic objects or features, perhaps hearths or similar types of things. But again, the important thing just to illustrate here is that because we're able to work with the data alongside the 3D terrain that we've got from the LiDAR, we're able to visualize where these features sit in the landscape in relation to each other. And that's a really important thing to be able to do in terms of interpreting this data and establishing what we think it represents. So in this case, my suspicion is that there are a series of enclosures and possible house stances within the earthwork that we were just looking at, the major earthwork that runs along the back of the image here, and then down into this area where we surveyed here, where the possible buildings and other features are. So really sort of useful visualization technique for interpreting these different data sets together. And when I talk about interpretation, that's really what archaeologists are trying to do when they're surveying sites. So this image that you can see on the left here is a very sort of traditional, typical archaeological survey. And although it seems simple and schematic, what it's doing is it's representing what the surveyor has understood that site to be. So the different relationships that you can see on that site on the ground have been translated into a sort of drawn version, which is, a simplified schematic interpretation of that earthwork. But it's really useful to be able to work with these things together. So not just re-interrogating sites that have been recorded by other surveyors, some of them, 50, 60 years ago, and looking again at them in relation to the terrain with the benefit of this 3D data, but just being able to depict sometimes more clearly what we think those relationships are. So this is what field survey in archaeology is all about, is getting down on paper and being able to convey what it is you think this site's all about and what the relationships between those different features are. So in this case, again, we have probably the latest enclosure here in the center overlying these much earlier earlier phases of defensive enclosure here. And again, just looking at the 3D data helps convey that sense of relationship between those features. And again, just to illustrate the point, this is all three-dimensional data. So when we want to go back to sites and ask new questions about how these features might relate to each other, it's possible to pull this data up, you work with the visualizations, and ask new questions. So again, just for a field archaeologist like myself, the ability to go back to this data, its reusability, and its sort of having it at your fingertips on your desk is one of the most powerful things about it. And obviously, because it's all in three-dimensional measured coordinates, we're able to take new measurements of it, ask new questions, that sort of thing. So this just illustrates how we might do that. It has other uses though as well, beyond just visualization of archaeological sites, of earthworks. And this is an example of a site that we've been working on the Mackers in Wigtonshire, not too far away from the Rhins. And this is quite an important wetland site, something related to a crannog, one of these prehistoric wetland settlements that we get in quite large numbers in southern Scotland. This image on the right here just shows part of that site being excavated. It's now in sort of boggy, wet terrain. And one of the things that we were interested in doing was just establishing what the landscape of that site might have been when it was in use. And so what we're able to do is use the LiDAR data to effectively artificially re-flood that landscape. So working through a number of models, we're able to sort of establish what would it have looked like if we added, say, 0.5 meter of water to it, 1 meter of water to it. And just adding all these data sets together gives us a new view on what the landscape would have been like when the site was in use. And when we do that, and we combine it with things like coring data that we have from the sediments around the site, and we're able to establish that this site was probably built on a kind of peatland promontory jutting into a small loch here. So you can see this three-dimensional data just allows us to visualize what that wetland landscape might have looked like at the time of the site's occupation. And again, I just put this slide in just to emphasize, you know, some of the power of the resolution of this data. So again, this is just another example of one of these complex sort of multiple defences of this hill fort, and sort of Iron Age enclosure. These Iron Age hill forts respond really well to LiDAR, and they always look quite dramatic, so they're always a good way to convey the value of this data. But this image just shows you quite how powerful it can be. And this these ridges that you can see along the top of this earthwork, and then right in the center here, for those of you that have got a big enough screen, hopefully you can see where my cursor is going, but just a very faint trace of an internal palisade. And what that is basically the part of the ground that's slumped into the slot where the original wooden fence around the first enclosure that was built on this site was located. So, you know, really quite incredible fine-grained detail that we're able to extract from these landscapes by working with this data. So we're just going to turn now to have a look at some of the ways it's been used, not just by professional archaeologists, but in collaborative projects and community projects. And recently we've been working with the Whithorn Trust on Machars Waterbourne, again, not too far away from the area we're looking at now. And this map just illustrates the number of sites in the Machars that have been documented. And working with LiDAR, you know, with a local community group there contributing new sites, we're able to increase the number of documented archaeological sites in the Machars by about 300. So, you know, adding really considerable numbers of new features in unrecorded areas to the national data set. So all of this stuff gets compiled and published to what we call the National Historic Environment Record, also known by its website name of Canmore. So those of you that are familiar with that website will know that you can look those sites up and you know, read more about them, who recorded them, and what they're thought to be. So all of this new data that's being collated is being fed into these national data sets and adding to what we know about the archaeological landscape in these areas. So this is just an example of the type of site that was being recorded on the Machars Waterbourne project. Really quite sort of spectacular enclosure here. You can see the remains of buildings inside it. They're quite an extensive cairn field to the west of this enclosure, overlain by historic agriculture, you know, sort of medieval, post-medieval rig and furrow cultivation, but overlying these lumps and bumps, which are almost certainly Bronze Age period cultivation, and then this circular enclosure with its buildings, who knows, somewhere in between, possibly a medieval date. You know, so the power of LiDAR is that you're able to get so much information about what's been going on in a particular location just by looking at this data. So turning to the Rhins then, I just wanted to have a look at the types of site that you're very likely to be able to spot in the data. So one of the things that the Rhins is very well known for in archaeological terms are these promontory forts. So I've shown you lots of examples from various places in southern Scotland of these big upstanding earthwork forts, and there are several good examples on the Rhins. So these will be good sites to go and check out in the LiDAR data for yourselves. And I really recommend that you do that and take the LiDAR with you when you go out to have a look at these sites, because it really does give you a new appreciation of kind of the scale and complexity of some of these forts. So we've got good examples here. This is at Kemp's Walk, this one down at Kirkloughlin, sites that, you know, quite readily visitable, but not always all that easy to appreciate in terms of, you know, the sort of complexity and relationship between the earthworks that you can see on the ground. So, you know, visiting them, having looked at the LiDAR, or even if you're able to take images of the LiDAR with you, really sort of adds to your experience when you go out to have a look at these things. But again, like everywhere else in Scotland, you'll find around the traces, around the edges of modern farming areas, or around areas that have been heavily ploughed and cultivated, the survival of really quite impressive much earlier archaeology. So this is at Cairnmonfell, over on the west coast of the Rhins. And you can see that the coastal path itself runs round the base of the hill on the west side here. But you can see these really quite impressive examples of prehistoric hut circles. So there's one here, another one here with an associated enclosure. And then up on the hill itself, up on the top of the hill, the fragmentary remains of the prehistoric field system that was associated with the settlement. So this sort of archaeology relating to the Bronze Age, probably, you know, hazarding a guess at this site, you know, it's not excavated, so we don't have dates for it, but it's almost certainly 2nd millennium BC, you know, somewhere around about 1500 BC would not be an unreasonable date for the use of this site. And you can see that it, you know, it's just a really good example of really quite fragile and fragmentary archaeology hanging on the edges of modern cultivation, and well worth, you know, a visit if you can get up to it. But the LiDAR just gives us, you know, this really good appreciation of the extent and complexity of some of this archaeology. Other sites that you'll find in the Rhins are much more fragmentary and much more ploughed down. And this is why it's a good idea to work with all the data sets that are at your disposal. So hopefully some of you attended Charlotte's talk last week when she was talking about working with things like historic maps and the existing Canmore records. And when you start to do that and pull in all of this information that's available to you online, you can really start to find out quite a lot of new information about our existing archaeological sites and ones that are not well recorded. So this is at Rough Cairn, this earthwork here, and you can see it's marked on the first edition Ordnance Survey map. And there are some sort of fairly vague records of this site. No one's been particularly certain exactly what it is, but you can see that the LiDAR gives us this really clear visualization of this central earthwork. If I go back to the historic first edition map, you can see it marked on as a fort, but now it survives just as this ploughed down earthwork, this ring of this ditch in the center of the image here. And if I just put this aerial photograph up, you can see how it looks in these photos that were taken in the 1980s, I believe. So again, just sort of giving you a new dimension on, you know, the sort of the size and extent and some of the details of the archaeology that you'll be able to see using all of these data sources. And one of the things that it's you know, that the LiDAR allows you to do is to sort of build up this appreciation of landscape and landscape history. So not everything is about upstanding earthworks and forts and hut circles. This image happens to have a hut circle in it here, just in this part here where my cursor is. But the reason I put this one up, this slide up, is that it's quite a good example of, you know, sort of the signature that human activity leaves on the landscape. So this scarring that you can see in this image here is historic peat cutting. So peat cutting was quite, you know, extensively done across Wigtonshire for much of the historic period, and it's left really sort of significant and characteristic signatures on the landscape. So, you know, working with this three-dimensional data in a way that sometimes things like Google Earth and Google Maps don't allow you to do, you're able to sort of get an appreciation of the history of activity in the landscape and the way people have used it over time. So I've kind of been talking a bit about the Rhins Revealed, or the data that you'll be able to get as part of the Rhins Revealed projects. And one of the things that we're planning to do is make a web map available for you to look at this LiDAR alongside the historic mapping and Canmore data that I've been talking about. So I'm just going to quickly try to move screens, if you bear with me. Now I'm hoping that you can see that. Nick, will you cut in if you can't see it? But I'm showing you on my screen the web map from which we're going to put online for everyone to be able to use. And I just wanted to give you a quick illustration of how you can use it. So effectively, it works very similarly to Google Maps, the kind of things that most people are familiar with. So on the left-hand side here, you have layers. You have the Canmore points that I was talking about, which are these blue dots here. We have a layer for the Ordnance Survey map. which I can turn on and off. This is the first edition Ordnance Survey map dating from the 19th century. And then the LiDAR data itself, which you're able to zoom into and view just by clicking and dragging around. So you can see they've got a really sort of powerful tool for your own sort of investigations of the history and archaeology of the area. And by clicking on any of these dots, these blue dots, this gives you a direct link through to, by clicking on the URL there, that'll take you through to the Canmore entry page for that site. So this is the idea of this, is that, you know, there's so much that's known about the Rhins archaeology, but an awful lot that isn't already. And this sort of web map just brings all of these tools together in a way that you can work with them all in one place. So please do, we'll be circulating a link to the web map, and it will be going on the project website before too long. So please do have a look at it and check it out. See, okay, so, and then, as I say, the important thing when working with LiDAR is to make use of all these similar data sets that you're able to access from your computer as well. So Charlotte spoke last week about working with historic maps, and it's really in doing that, using things like the National Library's website, where you can really get you know, the most out of landscape LiDAR survey. Working with all the different historic maps through the different periods that are available through this website, you're able to sort of develop a really kind of in-depth understanding of how the landscape's changed, which areas have been forested, which areas have been taken into cultivation, for example. And that really sort of allows you to develop a sense of how the archaeology has changed through time, and how we've ended up with the patterns that we can see in the data today. The other website, of course, to use is PastMap alongside this data. So PastMap is the mapping version of Canmore. And again, it just allows you access to lots of data sources relating to archaeology and the historic environment more generally. So it's a really good place to have, you know, often when I'm working with LiDAR, I have PastMap open alongside it, so I can look at the data on the ground, but I can look up existing records from PastMap alongside it as well. So that's the other place to look as you're investigating this data for yourself. And one of the last things that I wanted to say was just about you know, when you're looking at LiDAR and trying to understand the patterns in the data, it's worth just familiarizing yourself with some of the geology and some of the natural geomorphology of the landscape as well, because that's important for recognizing which patterns have resulted in natural features. So a good example in Wigtonshire is the direction of the ice sheet. So looking up this, the British Geological Survey's website is a very good place to start for this sort of thing. And it just comparing some of these geological maps and these maps of glaciation and deglaciation patterns gives you an appreciation of the shaping of the landscape and how you know, archaeology will stand out against that. So just to give an example, the ice sheet that sat over southwest Scotland moved in this direction, and as it did so, it scored the bedrock in these very sort of recognizable diagonal lines from sort of northeast to southwest. And that's a useful thing to bear in mind when you're looking at the data, because anything that cuts across that pattern of sort of northeast to southwest is very likely to be anthropogenic, or a signature of human activity. So again, just all of these data sets that you're able to access, working with them together gives you good appreciation of you know, of how the landscape has come to look the way it does. And that's again just to kind of wrap up on the LiDAR side of things. That's really just what I think of it as being most valuable for, is sort of developing this appreciation of time depth and what's shaped the landscape. And this is just a screen grab from one of the areas of the Rhins down at the Tirali Brick and Tile Works. But you can see in this image alone, we've got the brick and tile works themselves and all the associated workings showing very clearly in the data. But we also have Kirkbride Church, a medieval church there, but we also have the there remains the fine spots of what's been marked on the Ordnance Survey map as a kilt. There's almost certainly prehistoric stone axe. So, you know, again, just an appreciation of the sort of time depth represented in any one particular piece of landscape. And again, LiDAR is such a useful tool for getting a handle on all that stuff. So I said that I would just wrap up by pointing you in the direction for those of you that are really keen on this stuff and really want to get started on working with it yourselves. Just a couple of slides just to point you in the right direction. And as I say, if anyone is keen on doing that and wants to know more, then please do get in touch with me. But I mentioned at the start of my talk the remote sensing portal, and that's the website where you can get hold of this data. So a lot of the images that I showed you tonight are derived from this data. If you go to the website itself, you won't find these grayscale illuminated images like I've been showing, but this is where you get the source data that allows you to produce them for yourself. And if you're going to do that, a couple of terms that you need to bear in mind are the difference between DSMs and DTMs. And this is where it gets into the sort of technicalities of it. But the data that you'll find on that website is available in two pre-processed formats. So you're able to download the digital surface model, which is all the data, as I described at the start, including things like buildings, trees, vegetation. And the DTM, which is an important difference, is the bare earth model. So that's data that's had that filtering process done to it already. And it's had things like trees, bushes and buildings all removed to give you that ground surface model. If you're really keen and you want to get into the 3D data itself, you can also download the data in LAS format, which is that raw point cloud that I was showing you earlier. So again, if you have a powerful PC, and you will need one because it's very sort of big data, it's sort of, you know, hundreds of megabytes of data quite easily, then you can download that three-dimensional data and open it up in free software. There's software called Cloud Compare, is very good for looking at three-dimensional point cloud data. Or you can download these TIFF files, which are the pre-processed, rasterized, gridded versions of the data. So again, just a bit of familiarity with the terminology if you are going to go onto that website and start looking to download the data yourself. And again, just to finish up, a couple of pointers for software. There's a free bit of software called QT Reader. For those of you, again, that might want to install that and look at some of this data yourselves, you can download that for free, and it will open up the TIFF files that you can get from the Scottish Remote Sensing Portal. And it's a really good way of just being able to rotate the data in 3D. You can do things like exaggerate the Z dimension to make things seem bigger or smaller than they actually are, which is a useful visualization technique. And you can do things like adjust the lighting and contrast and that kind of thing. So that's a good place to start too. For those of you that are really technical minded, there's the Relief Visualization Toolbox, which again is all free and open source software. You can download that. Again, open up one of these TIFF files that you can get from the remote sensing portal, and it will start to produce some of these more advanced models that I was showing, the multi-directional hill shaded models and that kind of thing. So again, that's the place to look if you want to carry out some more of these kind of advanced visualizations. And if you're familiar with mapping software, then all of this stuff is very much compatible with free and open source GIS software. So QGIS is a well-known GIS package that many archaeologists and many other professions use. But again, really powerful software and free and open source, so easily downloaded onto any computer. And again, it will natively read any of the data from the remote sensing portal. So those last few slides were really, I don't expect most of you to want to follow that path, but if you do and you're really keen on this stuff, then those are the tools that you need to get started. And as I say, if you do want to get into this stuff and you would like some more training in it, then please do get in touch and we can arrange something. But I think that's probably the place to leave it. Thank you.